Special forms of the utility functions. A utility function u dot is homogeneous of degree 1 if it satisfies u of alpha x equals to alpha times u of x for all alpha greater than 0. A utility function u dot is log homogeneous if it satisfies u of alpha x equals to log alpha plus u of x for all alpha greater than 0. Three popular examples of homogeneous utility functions are as follows. The linear utility function, which has the form ui of x equals to the summations of aij times xij summing for all j. The Cobb-Douglas function, which has the form ui of x equals to the multiplication of xij to the aij multiply for all j, and where the summations of aij summing for all j equals to 1. The lineative or fixed proportions utility function, which has the form ui of x equals to the minima of aij times xij, where the minima is taken for all j. We now define the constant elasticity of a substitution functional form, CES for short, which is the family of homogeneous utility functions of a particular importance in applications. A CES function is a concave function defined as u of x1, x2, x3 until xn equals to a term to the 1 over rho, where the term is the summations of alpha I times xi to the rho, summing for all I starting from 1 to n, where the alpha i's are the utility parameters, and the minus infinity less than rho less than 1, rho is not equal to 0, is a parameter representing the elasticity of substitution 1 over 1 minus rho. See Varian, 1992, page 13. CES functions have been thoroughly analyzed in Arrow et al., 1961, where it has also been shown how to derive, in the limit, their special cases, i.e. linear, Cobb-Douglas, and lineative functions. See Arrow et al., 1961, page 231. For row approach 1, CES take the linear form, and the goods are perfect substitutes, so that there is no preference for variety. For row greater than 0, the goods are partial substitutes, and different values of rho in this range allowed us to express different levels of preference for variety. For rho approaches 0, CES become Cobb-Douglas functions and express a perfect balance between substitution and complementary effects. Indeed, it is not difficult to show that a trader with a Cobb-Douglas utility spends a fixed fraction of her income on each good. For rho less than 0, CES functions model markets with significant complementarity effects between goods. This feature reaches its extreme, perfect complementarity as rho approaches minus infinity, i.e. when CES take the form of lineative functions.